Supernova remnant reveals green monster. June 2025, a new spectacle in the cosmos. On a quiet morning in June 2025, astronomers from around the globe tuned into a shared revelation: a supernova remnant located in a distant region of our galaxy was not behaving as expected. Buried deep within the data collected by NASA's Chandra X-ray Observatory, the Hubble Space Telescope, and the James Webb Space Telescope, a peculiar structure emerged, a luminous green plume twisting through the shredded remains of a massive star. Informally dubbed the Green Monster, this vibrant apparition sparked scientific curiosity and reignited age-old questions about what happens when stars die and what they leave behind. The discovery, the Remnant, officially designated G344.70.1, is located approximately 19,600 light-years from Earth in the Scutum constellation. Though this region of space had been monitored for decades, it wasn't until the synergy of multi-wavelength imaging, X-ray, infrared, visible, and even radio frequencies that scientists noticed the anomaly. What had appeared to be a relatively ordinary supernova remnant suddenly took on new significance when Hubble's high-resolution imaging revealed a serpentine structure glowing with a distinct green hue. This unusual feature spiraled away from the epicenter of the blast like a cosmic ribbon. Nicknamed the Green Monster, both for its vivid emerald color and its dauntingly complex structure, the formation appeared to be several light-years long. Its presence raised immediate questions. Was it a jet? A shockwave? A pulsar trail? Or something else entirely? Perhaps something never before seen? What is a supernova remnant? To understand the Green Monster, we must first revisit what a supernova remnant is. When a massive star, usually at least 8 times the mass of our Sun, reaches the end of its life, it collapses under the weight of its own gravity. The core implodes into either a neutron star or black hole, and the outer layers are violently ejected in a supernova explosion. What's left behind is a nebula-like structure of dust, gas, and energetic particles expanding into space. This is the supernova remnant. Over time, these remnants evolve, cooling and merging with the surrounding interstellar medium. But during their active phase, they are some of the most energetic and chaotic environments in the universe. It's here that cosmic rays are accelerated, new elements are scattered across galaxies, and the seeds for future star systems are sometimes sown. The mystery of the green glow. The first task was understanding why the Green Monster was green. Astronomers used spectroscopic analysis to determine that the hue wasn't just an artifact of imaging filters. The green coloration stemmed primarily from doubly ionized oxygen, O3, a common component in many nebulae that emits strongly in the green part of the spectrum. But what puzzled researchers was the concentration and configuration of the emission. Normally, O3 lines are diffuse, spread across a remnant or concentrated in thin filaments shaped by shock waves. In this case, the oxygen-rich structure was cohesive and dynamic, showing signs of turbulence and rotation. It even had a slight Doppler shift indicating movement not just outward but also laterally, as if it had been shot sideways from the explosion. This motion and structure led some to speculate that the Green Monster might be the remnant of a jet or beam emitted during the core collapse, a phenomenon not typically observed in standard Type II supernovae. This hinted at the possibility of a failed gamma-ray burst or a magnetobirth event, both rare and exotic types of stellar death. The role of the central object. At the heart of G344.70.1, astronomers detected a dense, compact object emitting pulsations, evidence of a neutron star. More intriguingly, it appeared to be a pulsar, a rapidly rotating neutron star emitting beams of radiation from its magnetic poles. Pulsars often leave behind trails or jets, sculpting the surrounding debris with their intense wind of particles. Could the Green Monster be a pulsar wind nebula, shaped by magnetic fields and accelerated particles ejected from the newborn pulsar? Further analysis seemed to support this idea. The alignment of the green structure correlated with the pulsar's axis of rotation. Moreover, time-lapse images from archival data showed a gradual lengthening of the structure over the past 2 decades, consistent with a steadily moving trail of energized particles. Still, questions remained. Why was the emission so strongly oxygen-based? What shaped the twisting, helix-like morphology, and why had it not been seen before? A glimpse into stellar alchemy. The abundance of oxygen in the Green Monster is more than just a spectral curiosity, it speaks to the nuclear processes inside the progenitor star before it exploded. Oxygen is one of the last elements formed in a massive star's life, created from carbon during fusion just before iron brings the fusion process to a halt. The prominence of oxygen in this structure suggests that the star had undergone significant internal mixing prior to the explosion, and that the explosion itself may have been asymmetric, sending this green streamer outward like a bullet. The twisted shape might even record the magnetic turbulence during the star's final moments. In this light, the green monster becomes a historical record, a fossilized trace of the forces and dynamics at play during one of nature's most violent events. The broader implications. While beautiful and mysterious in its own right, the discovery of the green monster has implications that stretch far beyond this one remnant.
Thanks for watching, and subscribe for the more video.